Hi, my name is Christian Imon. I'm head of data management and data science at Skagerak Kraft. Skagerak Kraft is a Norwegian hydropower producer with 52 fully and partially owned power plants across the southern Norway, altogether producing an annual average of 5.9 terawatt hours, roughly the consumption of 300,000 households. The company's main focus is producing green electrical power, and our main value streams include water management and power trading. Water in our reservoirs, that's our main resource. The physical power markets that we operate in incentivize us to spend the water when the demand is highest. And in order to do that, we need accurate forecasts of power demand, of inflow, of available production capacities. And we also play an important role in preparing the river basins that we operate in for seasonal floods to minimize their damage impact. So our power stations, they need to be ready to meet peak demand by monitoring and receiving early alerts for potential critical issues. And it's more important that we plan downtime according to market forecasts. The operational patterns for our power plants are changing, so it's very important to have reliable access to asset data. In my current role, I have an overall responsibility for our data governance program. Our company has put data value maximization as a strategic priority, meaning that we aim to make it easy for everyone in our company to find the data that they need and process the data with tools that are appropriate to them. And the unit that I work in are the main facilitator for tools and practices to make this happen. We have long known that even small improvements in our forecasts for inflow and for price, that can make a very great impact on the revenue. And data is key to improving these forecasts. Plus, if we do better water management and calculations of water flows, that also ensures that we stay within the restrictions that we have on water flow in our waterways, which preserves the vital life there. Yeah, so let me explain a little bit about why we put high importance on data. 2 years back, we had our strategic direction for data value maximization already set. We had developed a good workflow for extracting telemetry data into a data lake, and we built our own operations portal, which is widely used by our field workers. However, this data lake we had was itself becoming a silo. It was difficult to sort of deliver on other needs than those that were met by the operations portal, such as like root cause analysis of problems. As a result, we often would receive requests to extract sensor data into an Excel sheet or create a plot or something for more deeper analysis demands. This wasn't particularly painful in itself, but we saw that there was an unfulfilled potential in liberating the data even more, such that the people needing data would have faster access to this data and support data-driven decision-making. We're committed to deliver on the strategy that we have of data value maximization by making data more accessible across business domains to better manage and monitor our water and our assets. Using Cognite Data Fusion as our data foundation, we can move the technical people that we have closer to our main value streams so that they may combine their technical knowledge and domain knowledge and then generate the highest impact where it matters the most. So now let me show you how we use Cognite Data Fusion to improve our processes and operations. And first, I want to show you an example of a Grafana dashboard that was built by one of our operators. This was made for tailored monitoring of a specific power plant. I won't go into the details of this dashboard, but the very nice thing about this is that it's been developed by a field operator that knows this power plant very well and knows that there are specific things that needs to be monitored about this specific plant. So here is monitoring the cooling waters for both generators, some temperatures at the stator on the generator. Yeah, looking at the frequencies, and he's able to get a bird's eye view on the status of that specific power plant, making it easy for him to know what to plan of activities for that power plant that specific day. Yeah, so another example I want to show you is how we can easily use charts to monitor when the water level difference across a trash rack gets too high. So we have trash racks on all our inlets, intakes, and that collects debris floating down the river. And what happens if a lot of debris is gathered at the trash rack is that it's more difficult for the water to get through. So I'll show you here how we monitor this. We can look here. These are the water levels before and after the trash rack. And by just looking at these graphs, it's quite difficult. But using a simple thing like this calculation function in charts, here pre-made a little bit, we're just subtracting, getting the difference between the two sensors. And looking at that, I can then even remove these two. You can see that for the while here, a couple of months, the difference between the water level in the trash rack is gradually increasing, meaning that there's a gradual buildup of debris. So here we could set a monitoring task to trigger, say, when this difference is more than 7 centimeters or something like this. And our operators would know that it's time to clear the trash rack. What happens here is that the power plant was standing still. So then the water level between the two sensors is more similar. So I'll show you one final example in charts, but what we will see now is how one type of time series, a water level, has been used to calculate a water flow. The calculation here is not used in done in charts, it's done using a Cognite function. So here we can see the two time series, a water level time series at the bottom. We're using a table with some parameters, this one here, which are input to the Cognite function running, and then calculating this time series here, saying that we have some water flow at each point. And you can see in this particular case, we have a normal water flow of about 0.7 cubic meters, and there was a big flood here in September, more than 100 cubic meters at some point. And this time series here, that's stored in Cognite Data Fusion and available for use outside also charts and for other users. All right, so the value of the examples that I showed you is, maybe it's obvious, but it really helps also to our operators to improve the operational decisions that they make, operate assets more in sort of a proactive mode. It helps them to be more independent, to sort of make have the data available to them, not having to ask anyone else to get insight into what's going on. The water flow time series that I showed in the end here, that helps us tune the inflow models that we have, which again gives us better inflow forecasts, and yet again that gives us a higher precision in the power markets that we operate. And it helps us also monitor the environmental impact that we have, and basically avoid harming wildlife. So moving forward, Cognite Data Fusion will be a central part of our data infrastructure and serve as a hub for and also for ensuring data quality across business domains. While we are still early in our work with Cognite Data Fusion, it helps our engineers already allocating the data that they need for root cause analysis and for monitoring. With still several features of the platform that we want to explore. We started our transition to data models already. We still need to link up documents and 3D models and images and other sources to enrich the data more and to make it more accessible to users. Me personally, I'm really looking forward to Cognite's Atlas AI, which I think should give us a flying start in the use of agents for more domain-specific tasks. And I think we have barely touched the potential of managing water level time series, where the sensor data can be combined with automatic and manual corrections and compared to inflow forecasts and production plans. All this will help us detect sensor failures, improve our predictions, and provide our production and maintenance planners with even better decision-making support.